Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the XXE injection module, titled Exploiting Blind XXE to Exfiltrate Data Using a Malicious External DTD. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on XXE injection, and select lab number 5, titled Exploiting Blind XXE to Exfiltrate Data Using a Malicious External DTD. Alright, let's get started. This lab has a checkstock feature that parses XML input but does not display the result. To solve the lab, exfiltrate contents of the XXE hostname file. And then you've got a note over here that says to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use the provided exploit server and/or burp collaborator's default public server. Alright, so the target goal over here is to exploit an XXE injection in order to exfiltrate the content of the XXE hostname file that is available on the server where the application is installed. And in the note over here, it says you could either use the professional version of burp to complete this exercise, or you could use the public server that is available for you in the lab. Alright, let's access the exercise. Now note over here, this is the built-in browser in burp, and so all my requests are already being passed in my burp proxy. What we'll do first is we'll complete the exercise using the professional version, and then in the next part of the video, we'll complete the exercise using the default public server that is available in the Academy, just in case you do not have the professional version. Alright, let's make this a little bit smaller so that the UI looks proper in front of us. Okay, this looks good. The first thing we need to do is find a parameter in the application that sends XML input to the backend. So we're going to click on View Details over here, and we'll analyze the requests in burp. As we do that, click on Check Stock and send this request to Repeater. Now, if we look at Repeater over here, we've got a post request to the /product/stock endpoint, and it takes in XML input. So whenever you see XML input, you definitely need to test for XXE injection. Okay, so let's hit send right over here. You could see it displays the number of stock for the product ID 1 at store ID 1. What I'm going to do is just put in a parameter that is used in XML and see how the application responds. And okay, so you could see over here it says invalid product ID. It doesn't directly tell us that it parsed this character as XML, but what it does tell us is that the application does not provide the raw output of, let's say, the error, or potentially if we were able to exploit an XXE injection, it doesn't provide the raw output of our exploit. And so we're stuck with a blind XXE injection over here. So the first thing we're going to do is, as usual, try a general entity, and if that doesn't work, we'll try a parameter entity. So let's remove this and start off with trying our general entity. So first thing to do is define the DTD, so doc type. We'll call it test. And then we'll define our external entity, so entity. We'll call it XXE, and it's external, so we'll use the keyword system. And then we're trying to ping a server that we have control of. So for this one, we'll use burp collaborator. Click on burp collaborator client, and let's put this right over here. Copy to clipboard, and then add HTTP, and paste our URL. And then let's close off our entity. And then next thing to do is just call the entity within the parameter. And so the way to do that is using the ampersand XXE and then the semicolon sign. Let's hit send. And we get an error saying entities are not allowed for security reasons. So it looks like we can't reference entities within the document. And so what we're going to try is try and reference it using a parameter entity. So let's hit send over here. It says invalid product ID, and that's probably because we have an extra space. So let's hit send again. And it still says that. So here we go, hit send. And I still get invalid product ID, which is weird. Let's remove this entire thing. Hit send. Yes, so something is definitely wrong with my request. It's probably the indentation over here. What we're going to do is we're just going to go back until we have the request without any of the exploit. Here we go. So let's remove this, hit send, and we get a proper response. Now let's add our general entity, but not reference it, hit send, and we still get 822. Okay, so it looks like it's blocking the reference to the entity when we put it inside the document, but it's not blocking the entity itself. So what we're going to do is we're going to apply what we learned in the previous exercise, which is parameter entities. So to do that, there was just a few differences between a general or regular entity and a parameter entity. So this one requires a % right over here. And let's make that a little bit bigger. And then in order to reference it, you reference it in the DTD itself. So we do that right over here. And again, instead of the ampersand sign, we use the % sign. So XXE and a semicolon. All right, this looks good. Let's hit send. We get an XML parsing error, but we don't get the custom error saying that entities are not allowed. So I'm very hopeful that this is going to work. Let's hit pull now. And it did. So you could see we get a DNS request and an HTTP request from the server that is running the application. Okay, so this is really good. We've proved that it is vulnerable to a blind XXE injection. Now what we need to do is take this exploit a little bit further and exfiltrate data from the application. Now, to do that, we need to host a malicious DTD on our attacker-controlled server, which is already provided to us in the lab. So we can do that directly through Burp Collaborator. So what we're going to do is we're going to go to the lab right over here, go to the exploit server. And in the exploit server over here, we're going to add our malicious DTD and then call the malicious DTD directly from this request over here. So for the malicious DTD, the first thing we're going to do is create a parameter entity. So %, we'll call this parameter entity file. And it's an external entity, so we use system. And what this does is it references the file that we need to exfiltrate or read from the server. So if we go back to the exercise over here, the file that we need is the XXE hostname file. So we'll add that right over here. That would be file, XXE, and hostname. So what this parameter entity does is it essentially outputs the content of the hostname file. Now the next thing that we need to do is create another entity. So we'll call this one eval. And the trick over here is to have an entity within an entity. So let's write this up and then explain it. All right, so we'll create another external entity. And we'll call this exfil. And then what this will have is our attacker-controlled server. So let's go back to Burp and copy our URL over here for our attacker-controlled server, which is Burp Collaborator. And again, in the next part of the video, we'll do this manually. And then we're going to say append the contents of the parameter entity file to the attacker-controlled server. Okay, this looks good. And then we'll call eval, and we'll also call exfil. And again, I'll explain this in a bit. And over here, what we're going to do is we're going to call our malicious DTD. So let's say doc type, And we could keep this as test and an entity, XXE, system. And instead of calling this over here, which just pings our collaborator server, what we're going to do is we're going to get the URL to our DTD, which is hosted on this server over here. So technically over here, we're using two servers in order to perform this exploit. But again, in the second part of the video, I'll just show you how to do it with this server over here. So let's put it in here. And then call the external entity. Okay, this looks good. So essentially what will happen over here is we've got our regular parameter entity. And instead of just pinging our collaborator server, what this parameter entity says is it says load this URL over here. Now, when you load this URL over here, what you'll have is a malicious DTD. So you've got an external DTD that has a bunch of XML commands in it. Now what happens over here is that it will call the eval parameter external entity and then the exfil parameter external entity as well. And what it'll do is essentially for exfil over here, it'll try to access this URL over here, which is our burp collaborator client. And then it'll try to append the input of the file parameter entity to the URL. So for the file parameter entity over here, if you look at what it's calling, it's essentially outputting the content of the XXE hostname file. So what'll happen over here is the content of the hostname file will get appended over here, and then the exfil entity will try to access this URL. So if we're keeping track of the access logs of our attacker-controlled server, which in this case is burp collaborator, we should see that an external server made a request to our server and then tried to access this URL in the server. Now, this is not a legitimate URL. This is just a URL that contains the content of the hostname file. Now, let's store the exploit over here. And hopefully this hasn't timed out. But essentially what we're going to do is hit on send. And we get an XML parsing error. So what it should have done right over here is process our malicious DTD, which is available on this URL over here, and then output the content of the hostname file. So if we go to burp collaborator client and click on pull now, we should have seen an entry over here trying to request our server, but we don't. So that means something is wrong with the way we wrote our script. And I know what the issue is over here because you have an entity within an entity, so it's within single quotes. This needs to be converted to its, I believe, hex format. So that would be the ampersand and the semicolon. Now this should work. Let's click on store again and then hit send and go to our burp collaborator client. Click on pull now. And we still get an issue, so there's still something wrong with our script. And I'm looking over here that I missed the semicolon signs. Hopefully this is what's causing it to not work. Let's hit store and then click on send and then go to burp collaborator client, pull now. And one last mistake over here. This should be a single quote, not a double quote, because you could see over here we've got a single quote over here, and this ends this one right over here. Let's hit store and then send again and go to our collaborator client, pull now, and here we go. So you could see we do get a DNS and an HTTP request. And if we look at the HTTP request, you could see that the application is trying to access our server, and then it appends to it the content of the file entity, which is essentially just the content of the XXE hostname file. So if we go back to burp collaborator client, what you could do is just copy this right over here and then click on submit solution and submit it. I won't submit it right now because if I submit it, my attacker controlled server will disappear. And so instead, I'll show you the second part of the video, which is how to solve this just using the attacker controlled server. So the first thing that I'm going to do is copy this because we made a few mistakes in it, and I'm just going to post it in the notes.txt document, and the link to the notes.txt document is available for you in the description of the video. So this is for burp collaborator. Now without Burp Collaborator, it's very similar, so we're just going to copy this entire thing right over here. And instead of pinging our collaborator client, we're just going to ping our attacker controlled server, which is provided for us in the application. So we just copy this and put it in here. That is it. Okay, so what happens over here is if we go back to our request, you could see over here that our malicious DTD is available on this server. So what it'll do is it'll essentially download the DTD and then process it. And in the DTD itself, we'll have our new one. So let's copy this and then put it in here and click on store. So what this will do is output the content of the hostname file and then append it to a request that is made to this server over here instead of Burp Collaborator. And then when this request is made, we just view the access logs of this server and then get the content of the hostname file. So let's go back to Burp, hit send to perform the request, and then go to access logs over here. And you could see we got the content of the hostname file. So let's copy that. Submit solution, paste it in here and click OK. And here we go. It says, congratulations, you solved the exercise. All right, so we successfully completed the exercise by exploiting the vulnerability using Burp Collaborator, and then we completed the exercise using the attacker-controlled server that was provided to us in the Web Security Academy. In the next lab, we'll look at another case of an XXE injection vulnerability.